The day we leave Earth could be closer than you think. Earth will not last forever. Since the moment human beings first looked up at the sky and contemplated the immensity of the universe, a question has endured for millennia. Are we alone? But today, in the 21st century, another question imposes itself with urgency. How much longer will we be able to keep living on this planet? Earth, magnificent as it may be, is not an eternal refuge. Human activity has triggered an unprecedented transformation, altering ecosystems, changing the climate, and pushing the planet toward critical limits. The need to search for new worlds no longer belongs solely to the realm of science fiction. It has become a scientific and ethical imperative. Advances in astrophysics and space exploration have made that search something tangible. The discovery of exoplanets located in habitable zones, the constant improvement of space telescopes, and the development of more efficient propulsion technologies suggest that humanity's future could lie elsewhere. It is no longer just about understanding how the universe works, but about finding within it a second home. The question is not if we will one day leave Earth, but when and where. The Kepler project, for example, has identified thousands of planets orbiting other stars. Some of them present conditions similar to those of Earth: dense atmospheres, moderate temperatures, liquid water, and, in some cases, a chemical composition compatible with forms of life as we know them. Modern science no longer searches for intelligent life among the stars as a mere fantasy, but as a real possibility. What a few decades ago seemed like madness is now studied in laboratories, universities, and research centers around the world. The concept of planetary habitability is redefined daily. It is no longer limited to planets exactly like Earth. Now, worlds covered in oceans, icy giants with warm inner moons, and even planets orbiting dying stars are being considered. Science has expanded our imagination, but it has also grounded us in reality. If we want to survive as a species, we must look beyond the blue sky that covers our current home. Life may exist in places we never imagined. For a long time, science assumed that life could only exist under conditions similar to those on Earth. However, the discoveries of recent decades have completely challenged that assumption. In the depths of our own oceans, where sunlight does not reach and temperatures are extreme, vibrant ecosystems have been found thriving around hydrothermal vents. There, unknown creatures feed not on the sun's energy, but on the heat and minerals emerging from the planet's core. This finding has rewritten the manual of what we understand as life, and has expanded the possibilities of where it might exist beyond our world. Based on these revelations, astrobiologists have begun to consider an ever-growing list of potentially habitable places. One of the most fascinating is Enceladus, a moon of Saturn covered by a thick layer of ice, beneath which lies a liquid ocean powered by thermal energy from its core. Space missions have detected plumes of vapor and organic compounds erupting from its surface, suggesting it could harbor simple life forms. Another example is Europa, a moon of Jupiter with similar conditions, where the combination of liquid water, energy sources, and essential chemical compounds opens the door to the possibility of extraterrestrial life. Even Titan, with its dense atmosphere and lakes of liquid methane, raises intriguing questions. Although its chemistry is radically different from that of Earth, the possibility cannot be ruled out that some form of life, based on entirely different structures, has evolved there. The existence of life does not necessarily mean it must resemble us. It could be invisible, silent, microscopic, or unimaginably different. But if it has arisen once in the universe, it could have arisen many times. Life as we know it is only one of many possibilities. The universe, with its unimaginable vastness, could be full of surprises. And if there is one thing we have learned as a species, it is that the more we explore, the more we realize how little we know. Our ignorance is as vast as the space we intend to conquer. Not all stars are like our Sunday. When we imagine habitable planets, we often think of worlds orbiting stars, similar to the Sunday. However, astronomical reality is much more diverse. Of the thousands of exoplanets discovered in recent decades, most do not orbit stars like ours. In fact, most of the stars in the galaxy are red dwarfs, much smaller and cooler than the Sun, but also more long-lived and common. This raises a fascinating question. Could there be life on planets that orbit these stars? The short answer is yes, but with caveats. Red dwarfs emit far less energy than the Sun, so their habitable zones are much closer to the star. This means a planet would need to be at a very short distance to have temperatures suitable for liquid water. However, This proximity also exposes planets to intense stellar flares, capable of destroying atmospheres or sterilizing entire surfaces. In addition, planets so close are often tidally locked, always showing the same face to their star like the Moon with Earth, one side scorched by heat and the other plunged into eternal cold. Despite these challenges, some scientists believe certain conditions could mitigate the extremes. A dense atmosphere, for example, could redistribute heat between the day and night sides, or a global ocean could maintain a more stable temperature. Some models suggest that even under such different circumstances, life could adapt and thrive. And there's more. Some stars much larger than the Sun live short but incredibly active lives. Although their lifespan as stars may be just millions of years, they could host systems with moons or habitable planets for shorter periods of time. In this sense, life would not have to be exactly like ours. Favorable conditions for a brief period could be enough for simple life forms to emerge. The universe does not settle for repeating patterns. At every step we take in studying it, we discover there are more exceptions than rules. Life, if it is truly a natural consequence of cosmic chemistry, could flourish even in places where we would never expect to find it. The real search for habitable worlds. Beyond fiction, humanity has already begun the active search for habitable planets in the universe. Thanks to telescopes such as Kepler, Hubble, and now James Webb, astronomers have identified thousands of exoplanets, many of them located in what is known as the habitable zone of their stars. This zone is the range of distances where conditions could allow the existence of liquid water on the surface, which is an essential requirement for life as we know it. But finding a planet in the habitable zone does not mean it is a paradise. It is still necessary to determine whether these planets have atmospheres, whether they have magnetic fields to protect them from stellar radiation, and whether they actually contain water. The new instruments on the James Webb Space Telescope are specifically designed to study the composition of these exoplanets' atmospheres. By analyzing the light that passes through them, we can detect the presence of gases such as oxygen, methane, or water vapor, potential indicators of biological processes. One of the systems that has generated the most excitement is TRAPPIST-1. This red dwarf star, located about 40 light-years from Earth, hosts at least 7 rocky planets, 3 of them within its habitable zone. What's fascinating is that all these planets orbit very close to their star, meaning that a full year on these worlds could last only a few Earth days. Although they face challenges such as tidal locking or stellar activity, their relative proximity and compact configuration make them ideal candidates for future detailed observations. Science is also exploring other revolutionary ideas, for example, searching for signs of life not on the surface, but in the atmospheres of gas giants, or even in the subsurface layers of icy moons, such as Enceladus or Europa. These moons in our own solar system have already shown evidence of subsurface oceans, hydrothermal vents, and organic molecules, key ingredients for life. The future of space exploration may not lie in manned rockets crossing galaxies, but in satellites and telescopes that decipher the light spectrum of distant worlds. Because in every star, every planet, and every small point of light, there could be a second Earth waiting to be discovered. If you are passionate about these journeys through the cosmos and want to keep exploring the mysteries of the universe with us, subscribe to Midblown Space, turn on the notification bell, and join us in every new episode. Here, the wonder never stops.